Welcome back to Click Future, where your future is a click away. This is the final episode in our Quantum Horizon series, where we've explored the fascinating intersections of AI, quantum computing, and space achievements. Throughout this series, we've examined revolutionary technologies that are transforming our world. Quantum computers that harness the strange properties of quantum mechanics, artificial intelligence systems that can learn and adapt, and ambitious efforts to explore and utilize the resources of space. Today, we're exploring how these technologies are not just advancing in parallel, but converging, creating synergies that could reshape humanity's future in ways more profound than any single technology could achieve alone. From solving existential challenges like climate change to enabling a multi-planetary civilization, from augmenting human capabilities to transforming our understanding of consciousness itself, the convergence of these technologies opens possibilities that once seemed like science fiction. Arthur C. Clarke famously observed that any sufficiently advanced technology is indistinguishable from magic. Today, we'll explore how the convergence of AI, quantum computing, and space technology is creating what might indeed seem like magic to previous generations, and how it might shape our collective future. To understand the power of technological convergence, we first need to recognize how these fields are already beginning to intersect and amplify each other. Artificial intelligence is becoming essential for space exploration. Autonomous systems guide rovers on Mars, analyze vast datasets from space telescopes, and will soon manage complex operations like asteroid mining and off-world manufacturing. Quantum computing offers unprecedented computational power for simulating complex systems, from the behavior of spacecraft in multiple gravitational fields to the molecular composition of alien atmospheres. These simulations enable missions that would be impossible to plan with classical computing alone. And space technology is driving advances in computing and AI. The extreme requirements of space missions, minimal size, weight, and power consumption, combined with maximum reliability, push the boundaries of what's possible in computing hardware. Throughout history, major technological revolutions have often come not from single technologies, but from their convergence. The Industrial Revolution wasn't just about steam engines, but their combination with new manufacturing techniques and transportation systems. The Digital Revolution wasn't just about computers, but their convergence with telecommunications and the Internet. The most transformative periods in human history occur when multiple technological revolutions converge, creating possibilities that no single technology could achieve alone. We appear to be entering such a period now. We're already seeing early examples of this three-way convergence. NASA's Quantum Artificial Intelligence Laboratory, QUAIL, uses quantum computing to optimize mission planning and analyze complex datasets. The European Space Agency's Advanced Concepts team is developing quantum algorithms for spacecraft autonomy, and private companies like SpaceX are incorporating AI into every aspect of their operations. Perhaps the most important potential of this technological convergence is addressing humanity's greatest challenges, problems that have proven resistant to conventional approaches. Climate change presents extraordinarily complex modeling challenges. Quantum computers could simulate Earth's climate with unprecedented detail, while AI could identify optimal intervention strategies. Space-based solar power and climate monitoring systems could then implement and track these solutions. Food security is another critical challenge. AI-optimized vertical farming, informed by quantum simulations of plant biology and utilizing space-derived technologies for resource efficiency, could revolutionize food production while dramatically reducing environmental impact. Our energy systems face the dual challenges of meeting growing demand while reducing environmental impact. Quantum computing could accelerate the development of room-temperature superconductors and fusion energy. AI could optimize global energy distribution, and space-based solar power could provide abundant clean energy regardless of weather or time of day. In healthcare, quantum computing could revolutionize drug discovery and personalized medicine by simulating molecular interactions with unprecedented accuracy. AI could analyze vast medical datasets to identify patterns invisible to human researchers, and space-based manufacturing could produce pharmaceuticals and medical devices with properties impossible to achieve on Earth. The convergence of these technologies gives us tools to address challenges that have seemed intractable. For the first time, we can realistically envision solutions to problems like climate change, resource scarcity, and global health crises. Beyond solving Earthbound challenges, this technological convergence could enable humanity to become a truly multi-planetary civilization. Establishing permanent human presence beyond Earth requires the ability to utilize in-space resources, what's called in situ resource utilization. AI-controlled, quantum-optimized autonomous manufacturing systems could transform raw materials from the Moon, Mars, or asteroids into habitats, tools, and even more manufacturing equipment. The holy grail of space development is self-replicating systems, machines that can build copies of themselves using local resources. This would enable exponential growth of off-Earth infrastructure. Quantum computing could design these complex systems, while AI would control their operation and adaptation to local conditions. Large-scale space habitats, supporting thousands or eventually millions of people, become possible when these technologies converge. Quantum computing can optimize complex life support systems. AI can manage day-to-day operations and resource allocation. And space resources provide the raw materials needed at scale. Looking further ahead, interstellar missions become more feasible. Quantum computing could help design breakthrough propulsion systems. AI would be essential for managing spacecraft that must operate autonomously for decades or centuries. And space resources could provide the vast amounts of fuel and materials needed for such ambitious missions. The bottleneck for space settlement has never been just rockets or life support or resource extraction. It's the integration of all these systems at scale. The convergence of AI, quantum computing, and space technology is finally giving us the tools to address this integration challenge. This expansion would transform Earth's economy as well. A space-based economy utilizing the virtually limitless resources of the solar system could end resource scarcity on Earth, enabling a post-scarcity economy where competition for limited resources is replaced by abundance and new forms of value creation. The convergence of these technologies won't just transform our external world, it could also fundamentally enhance human capabilities. Brain-computer interfaces, already in early development, could be revolutionized by quantum computing's ability to process the enormous complexity of neural signals and AI's ability to interpret and respond to them. This could enable direct mental control of devices, or even the sharing of thoughts and experiences between individuals. Augmented cognition systems, AI assistants that seamlessly extend our mental capabilities, could become far more sophisticated with quantum computing power. Rather than just answering questions, they could become true cognitive partners, helping us think through complex problems in ways that neither humans nor AI could achieve alone. Space medicine research, driven by the needs of long-duration missions, is advancing our understanding of human physiology and developing technologies to maintain health in extreme environments. These advances could translate to Earth-based medicine, extending healthy lifespans and enhancing physical capabilities. Genetic engineering and synthetic biology, accelerated by quantum computing's ability to simulate complex biological systems and AI's ability to design genetic modifications, could address inherited diseases, enhance human capabilities, and even create organisms designed for life beyond Earth. These technologies offer extraordinary potential to enhance human flourishing, but they also raise profound ethical questions about equity, identity, and what it means to be human. We need thoughtful governance to ensure these benefits are shared widely and used wisely. Perhaps most profoundly, as we explored in our 5th episode, the convergence of these technologies raises questions about consciousness itself. Could sufficiently advanced AI systems develop some form of consciousness? Could quantum computing help us understand the quantum aspects of human consciousness? Could space exploration bring us into contact with non-human forms of consciousness? The potential benefits of this technological convergence are enormous, but so are the risks and governance challenges. Advanced AI systems could pose risks if their goals aren't aligned with human welfare or if they're deployed irresponsibly. AI safety research is working to ensure that increasingly powerful systems remain beneficial, controllable, and aligned with human values. Quantum computers could break much of today's encryption, potentially compromising digital security. Post-quantum cryptography is being developed to address this, but the transition will be complex and challenging. Space development raises questions about resource rights, environmental protection of celestial bodies, and preventing harmful contamination in both directions. International frameworks like the Artemis Accords are beginning to address these issues, but much work remains. These technologies could exacerbate inequality if their benefits flow primarily to those already advantaged. Ensuring broad access to the benefits of technological convergence will require intentional policy choices and new economic models. The convergence of these technologies will create enormous wealth and capability. The central question is whether we'll use that to create a more equitable and sustainable world for all, or allow it to deepen existing divides. Addressing these challenges requires international cooperation. No single nation can effectively govern these global technologies alone. Initiatives like the International Space Station, global AI ethics frameworks, and quantum technology standards show that such cooperation is possible, though not always easy. Perhaps most importantly, the public needs to be engaged in decisions about these technologies. Democratic governance of transformative technologies requires an informed citizenry and inclusive decision-making processes. Throughout human history, technological revolutions have transformed how we live, work, and understand our place in the universe. The convergence of AI, quantum computing, and space technology represents a new revolution with unprecedented potential. In the coming decades, we'll likely see this convergence accelerate, creating capabilities that seem almost magical by today's standards. From solving our greatest challenges to expanding beyond Earth, from enhancing human capabilities to transforming our understanding of consciousness itself, the possibilities are extraordinary. The future that emerges from this convergence isn't predetermined. It will be shaped by the choices we make, as individuals, as societies, and as a global civilization. By understanding these technologies and engaging with both their promise and their challenges, we can help steer toward a future where their benefits are broadly shared and their risks wisely managed. This concludes our Quantum Horizon series, but our exploration of these fascinating technologies continues. If you've enjoyed this journey through the technological frontier shaping our future, please hit that subscribe button to stay updated on future content. And leave a comment below. Which aspect of this technological convergence do you find most exciting or concerning? In future videos, we'll dive into specific aspects of these technologies and their applications. Until then, this has been Click Future, where your future is a click away.